Hey everyone. Thanks for being here. Thanks that I can be here. My talk is a bit less technical and less kind of code. You will not see any code on a little bit. Generally, I want to talk about what it takes to become a great developer. First, before I really start, I want to give a disclaimer. Everything I talk about, is my personal, comes out of my personal observations. It's my personal opinions, and everybody can have a different opinion, and I'm happy to talk afterwards about it. A little bit about me, because when it's all personal and it's my opinion, and it comes out of my experiences, you might need to know a little bit about myself. So I'm a software developer. I started as a software developer at Spreadshirt, a t-shirt company, which is also the fact that I love t-shirts, and I probably have a t-shirt for every day in the year at home. Then I worked as a freelancer, and since 2013, I'm working as a CTO for various companies, from selling tires online for cars to dealing with fintech stuff, over to local services at Charlie, and now I'm with Oberlo/Shopify, which is an e-commerce store, which you might want to know. If you want to know more, we have a stand over there, and you can ask all your questions about Shopify and what we're doing. I also wrote a little bit the technology behind there, which I'm familiar with. So I'm PHP and Ruby, classic databases, classic web applications, so no C# and this kind of thing. So it's really the web experience. But it also plays not much role about what I want to say. Technology can be exchanged with whatever you use. But I want to or why I can say something there is because I probably had over 800 interviews in my life so far. Every month, I get some news, so I talk with developers in various stages, sometimes very early, sometimes in the middle of the process, sometimes I'm the last one in the interview process, but I try to speak with everyone which we get into the team. And what I'm looking there in these interviews is did this developer has the potential to be a good developer, and maybe there's even a small blink of this become a great one. So these are the people we want to have in our teams, these people we want to hire, and I will now explain a bit more what are the things I'm looking for there. So in order to figure out what is a great developer, we need to start with something smaller, so something earlier, what is a good developer. So I have used several approaches to this, but one thing is to see what makes good software. So when people who write good software, they are probably good developers. There are other things which you want to look for, it's a personal fit, how people behave, but the ability to write good software, I think it's a very good indication for a good developer. So what is good software? And maybe before we go deeper onto this, maybe I want to ask the audience very quickly on who here is not a developer, to make it easy. Okay, we have one guy in the audio room, and the rest is they're all developers, which is great. So everything I will tell in the next slides should be very familiar with you. So maybe I bore you, but please follow me and to come to the second part of the talk. So what is good software? Good software is a microservice and event sourcing-based agile serverless MVP with predictive AI trained by machine learning, written in Clojure. Who agrees? No one? It can work, but will be very challenging. So no, this is actually not good software. For me, good software is maintainable. And this is the core of what makes good software for me. And who's agreeing with this? Okay, people love maintaining software. Great, but to understand this better, what is maintainability? What is it? What do we talk about here? Is it just fixing bugs, or is it something else? So I found this definition. Of course, I Googled, and Wikipedia is a source of all kinds of definitions. This one is also from there, and software maintenance in software engineering is a modification of software product after delivery to correct faults, to improve performance, or other attributes. Very dry. So I looked again, what else can be used to define maintainability or maintenance of what is maintenance. And like Canvas, like another definition of like what you do when you do maintain a software. So there's like some studies out there, and they figure out like what are the engineers doing in various companies when it comes to maintaining the software. And they do a lot of things to maintain. One thing, they adopt the software for changes in the environment. That's the adaptive part. They also like make it more perfect, more better suitable to the users who are using the software. There are new requirements or change requirements, so that's another piece where people change delivered software, so it makes it better. Then there's this piece which a lot of people like always put in parallel to maintenance, is meaning fixing bugs. So there's like, of course, things go wrong, like we're not perfect, so you need to correct things. And then there's a piece which is like preventive, which makes it more resiliency and like which makes it behave better when errors occur, so make it just a bit more stable. So these are like the 4 different things people do when software is delivered and it's deployed. And like when you look deeper into these numbers, like 75% are about the first 2 things. So it means there is a change in my software environment, I have a change in the user requirement, I have new functions like my users requires, so I need to change something. I need to like do something there. Only 21% is about like fixing bugs. And the little rest which is there is like make things a bit more resiliency. So I think that can become more, but like we focus on the first 2 things. And what it actually means is like I make changes to the software I wrote before. I really put new user requirements into my software. And this brings me to this like one sentence, which I adapted a little bit, and I say like change is the only constant in a software development. So that's what always comes to you, like there's a new requirement, like your product manager, your business person comes to you and say, hey, we need to change this. We need to adopt this. We need to build something new. And so like you need to be ready for this. Like there's no way to avoid this. You can say, no, I don't want to make this change. You need to do it because otherwise your business goes down. So you need to support change. So how can I support change? Like what can I do as a developer better to like make my software more changeable or more adaptable, more maintainable in this name? One thing is like write clean code. I think that's quite common, like everybody understands what clean code is. I don't need to go into that much details there, but like it's in the end like have less what the fucks, you know? And what you do like there, you don't like only write clean code for yourself. So you definitely write for yourself because like when you're 6 months later after you wrote some code, you have to read it again. It's easier if it's like written in this kind of having the clean code product in mind. For your team members, which never saw your code you wrote, like it's also helpful if like it's readable and understandable and simple. And it's even more important. Sorry that I'm jumping a little bit, but my slides, my notes are not there. But like it's even more important because there are a lot of reports or like scientific researches about like our life that said we are reading 10 times more code than we write. So we need to support this. We need to help us there, and clean code is like a really, really good way to do it. How to do it? Like I totally recommend these 2 books. Who has read at least one of these? Okay, not all the arms are there. So definitely, it's like it's a very good investment in your career. What else is helpful for maintain code? Let's make it changeable. So I think like there are a lot of things like I mentioned in the talks before, how to make your application more changeable. There are a lot of like the adapter concept of Laravel is like a very good example how to make it very easy to exchange underlying infrastructure or underlying service without making any change to your application because you built against this adapter. But it comes down to like functions which are like can be exchanged, which are like have a clear, or classes which have a clear API from the outside, and you can change the internal implementation. So always think about this, like make all your parts of the software, no matter if it's like the functions and classes up to like architecture components, in a way that you can change them, and you can change them into like something different. Because you don't know if you like, in like 1 year, if you still like want to have everything in one database, you might want to split things up. You want to like use 2 databases. You want to put search somewhere else. So you want to like Elasticsearch instead of MySQL search. So as earlier you think about like how to exchange things and make it changeable, like the better it is. Documentation, like who of us write documentation about their projects? Some people. Here I don't talk about code documentation, that's why we have clean code, that's documentation enough for the code. We have tests which also document your code. I'm talking here about helping other people to understand what you built and how it runs and how it gets to your server and how it runs on the local machine. So imagine you get a new developer in because you're growing, your business is doing great, and this person needs to understand how you build things. It's better you have document this part, the better it is for him, and at faster he can help you, and so you have to do less. So documentation means documenting how the application is to set up, how my local environment works, how the deployment works, maybe giving some high-level architecture overview so people understand this piece they're working on in a bigger scope. You don't have to write method documentation. I don't think that makes any sense. Tests. I hope everyone is writing tests in terms of unit tests, functional tests, proving that what you build works, right? Someone is not writing tests? Bad question. Okay, that's really good. So it's very obvious. I don't need to go deeper on this. But tests tell you if when you make a change, that everything works afterwards. So it's essential for any maintenance is that you have tests. If you work on a system which has less tests, the first thing you do before you make any change, you have to write tests to cover at least the basic functionality. Otherwise, you can't exchange things. We'll run into a nightmare, and you don't want to do this. Monitoring, logging, and metrics. I think that's also very obvious. You want to understand that when your application is down. So you want to see why it's down, why it's slow. So you need some kind of monitoring. Later, if something goes wrong or something is not behaving as you expected, you want to have logs. And I totally recommend to put some kind of traceable stuff in there, so things which allows you to group log messages in a meaningful way, see everything which happened in the request, so add the request ID to your log messages, add a session ID to the log messages so that you are able to understand is this error happen in the session, is this error happen in a request. If you have a distributed system or a system based on microservices, you need to be a bit more smarter there. So you need to add some kind of traceable IDs to your request, which you send through your architecture to enable to achieve the same thing. Because all these backend API calls or the backend calls to your services, they also should be part of a bigger request cycle. So in order to do this, you need to add extra stuff to your calls to your services. But this will all help you later to get some meaningful information out of your log files. Another thing which really helps is having a standardized format and think a bit about what you want to index there, because all these kind of log tools they have indexable fields, so you can create all kinds of queries there, nice graphs, but it only makes sense if the ID is always the ID, if your request ID is always request ID across your whole application. If you name it request ID there, access ID there, remote ID there, you have 3 fields to index, and it's they all give you different information. So think a bit about how you log data and what kind of structure you use for logging. Last but not least, you want to know what your system is doing when everything is happy and everything works well. So for this, you need to have metrics. So dashboards, which allows you to see what's going on at the moment in the application, and which allows you to create all kinds of alerting when kind of a pattern of a graph of the, for example, the response graph. If this the response time gets up, you want to notice this very early on. So it's not only enough to collect the information. It's also important that you create the right dashboard for it and that you create the right triggers points inside your dashboard. Otherwise, you have nice numbers, but you don't see if a pattern there changed. Dashboards are all about identifying a specific traffic pattern, and then when this pattern is changing, you can either see if it's coming from a deployment, so deployment should be there, or you see if it's coming from an error or an issue, so errors should also be there, and then you can correlate a change in the pattern of the dashboard to the actual cause of this change. So think a bit when you build the dashboards that this is there. And last but not least, for maintainable software is I would say make it very easy to deploy things. make it easy to like have a CI, so automate all those kind of things. We saw that just like how easy it is to deploy with Docker. So like as more as you automate stuff, as better it is. So as easier it is for a developer to make a change and to implement a change, by just like merging like a branch into like the master branch, yeah, it's better this. So knowing all this, it's nothing new. Like, who is doing all these kind of things? Good, really good. So now the big question is like, what else should I do? Like, I do all these great things, software is great, or what makes a great developer now, based on all the information you just got? And like, I think it's like 5 points. And the first thing is like style. And with style, I mean, when you enter like a company and like that you not you do not try to force your style into the company, that you ask like, hey, how do you write code here? Where can I find some documentation? I want to understand how like this company writes code and how the company documents stuff, and where can I find it? Like, who are the other developers? Like, what kind of approach they take? So this means like they're adapting their own style to what the company is doing in order to achieve like one thing, which means like readability of the code and having like a clear approach to problems, because there's so many patterns out there, there's so many ways of doing things that like everything is right, but like a great developer is really like trying to change his personal style to be more adjusted to what the company is doing, and so behave or like achieve like a better work together effect. The other thing is like asking for like style guides, like from a front-end perspective, to say, okay, I don't want to reinvent the wheel here. Like when there is a style guide existing, I will follow. So that's the first thing like a new developer, a great developer, will do on the front-end side is like understanding how the style guide works and what kind of components are there, what kinds of like things are like used in the front-end in this company, and also like if this is not there, like of course like this great developer will like try to implement this kind of things because he understands the importance of it. So just an example here, that's our style guide from the Uberlo app. It just defines like a clear structure of like colors, like behaviors, elements on the UI. So just make sure that like this is all in place. And like another thing is like our handbook, where we say we document the way how we write software and like why we write it in this way. So what kind of pattern do we use? What kind of approaches we are using? This is documented, and like a great developer is first guy who asks it, or like who also contributes to it. Another thing is like understanding. It doesn't mean only like, oh yeah, I understand what to do. A great developer tries to really understand the deep, also the business reasons behind this. He wants to understand like why we have to implement this kind of thing in this way. He understands like how he wants to understand how a customer is actually using the feature. So he's just looking into much more than only the how I should do it and like what kind of technology should I pick. So they really seek for understanding. And this is a two-sided thing. A great developer also tries to look for understanding on the other side. So when the feature is like more complicated, like a great developer tries to help the business to understand this, the complex part of it, makes it understandable for them, and like helps that like you have a good, that you build the right thing at the end, which is like the piece on the down there. Now, like one thing more, like which happens to understanding is like communication. So do the opposite of like what is showed up there. It's like communicate across your normal disciplines. Not only talk to other developers, really talk to the whole company, to everyone in the company who's affected by what you do, and they will like talk more with you. So like you will see if you start doing it, they will do it back, and then it's a much better working together than before. It's about asking the right questions. So think about what you want to ask, what you want to know. But like a great developer is really someone who's outspoken, who goes to the other teams and try to look for alignment there. Learning. I think that's a very obvious thing. Like a great developer, is a constant learner. So he wants to not only master his craft and the stuff he's currently doing, he also thinks, okay, I can go beyond. I want to understand how our deployment works. I want to understand how our databases works. I want to understand how the framework works, which I use. So it's a constant kind of a curiosity, which a great developer has, and it goes beyond the pure technology part. So a great developer knows his weaknesses, and they want to learn how to overcome the weaknesses. And from my perspective, the most important piece for a great developer is the ability to share knowledge with others, to mentor people which are just starting, to mentor people which are just joining the company, to help them understand faster how things are working in this company. They not hoarding their kind of information and their knowledge and their access. They're the people who are really sharing this and trying to make everyone around them much better than they are before. So I think that's the most crucial skill a great developer has. And which also makes a real difference, because with you mentoring other people, you have a much bigger impact. You have a much bigger reach to the people, and you can achieve much more because you're not alone anymore. You have more people who have the same knowledge, or they will grow their knowledge, and this brings the whole company much further. It brings the whole project which you're working on much further, and it's just something which makes everyone more happy because they learn something. So it also fits into the slides before. Whew, rushing. So that's what's a great developer. It's a style, it's understanding, it's learning, it's communication, and it's mentoring others. So based on this, just want to make a check. And I know it's it's a bad question, but who thinks that he is a great developer? Good. So it's a great result. So please, we have a booth over there. Please all come to me. Let's talk. No, I'm also a bit fast, I think. So I'm done with my talk. Thanks a lot. It was very short, but I hope it helps. And we see us later there. Now we have a break.